Consider a science experiment where an object is dropped from the top of a tower and the distance it has fallen is measured at various times. Determine a formula for d in terms of t. If we take a difference, 4.9 take away 0 is 4.9. 19.6 take away 4.9 gives us 14.7. 44.1 take away 19.6 gives us 24.5, and then 78.4 take away 44.1 is 34.3. So the first difference is not constant, they're not all the same, so it's not a linear relationship. So we go ahead and take a second difference. If you do that, you'll find that they're all 9.8. That means we have a constant second difference, and that tells us that the relationship is quadratic. So d is going to be of the form at squared plus bt plus a constant c. A, b and c are all constants, or just numbers, that we're trying to find. Now, there is a slight shortcut to finding some of these. The constant second difference was 9.8. If we divide that by 2, we get 4.9, and that is the value of A. In this case, we know that d is 0 when t is 0. That tells us that c is 0. So far we have that d is equal to 4.9 t squared plus bt. Remember, the c is 0, so that disappears. Now just use another value. So d is 19.6 when t is 2. So 19.6 is equal to 4.9 times 2 squared plus b times 2. 19.6 equals 4.9 times 4 is 19.6, and that tells me that b is equal to 0. So I just have that d is equal to 4.9 t squared. Now we can find this using the calculator if we have it available to us. It's called quadratic regression and actually only needs 3 points. We'll use all of them. So if we go into statistics, what I'm going to do is I'm going to put my t's in list 1. So that's 0, 1, 2, 3 and 4, and then we'll put the d's in list 2. So that's 0, 4.9, 19.6, 44.1 and 78.4. Go to Calc Regression and we want quadratic regression. Our x's, which are what the t's do here, are in list 1. The y's, that's the d's, are in list 2. Click OK and you can see that we have ax squared plus bx plus c. A is 4.9, b is 0 and c is 0. So it's found the constants for us for this equation.